Okay, so we're going to look at p-values and how confidence intervals interact with hypothesis testing. So we're going to do some of the more theoretical stuff. Go ahead and look at the question, pause the video, answer it, and then let's see how you did. For number 4, a very low p-value provides evidence against the null hypothesis. Well, it would help us to know what the null hypothesis is. So we're going to state that our null hypothesis is that some proportion is equal to some value. If I have a low p-value, I say it's so small and I reject the null hypothesis. I have evidence against the null hypothesis. This is true. A high p-value is strong evidence in favor of the null hypothesis. Well, that's antithetical to part A, so absolutely not. You'll notice that there are key words here in C and D. The keyword true in both parts C and D are indicators that these are wrong. We are never sure of anything. We can never prove anything is true without an infinite number of highly specific experimental data. So your only true answer is A, the other 3 are false. From the data you see here, go ahead and try and write your null and alternative hypothesis and tell me if they're one-tailed or two-tailed. If you don't want to do all 3 of them, do 1 or 2 and then check your answer. How do we know if it's one-tailed or two-tailed? Number 5 gives us the term changed. Changed means more or less. It's not unidirectional, therefore it is two-tailed. For part B, we're given a specific term, greater than. Greater than, greater than. C is tricky. How do we know that P is 0.5? Well, we're talking about majority. So we need to know from our civics classes that majority means more than half. So that would set my p-value at 0.5, and if I want a majority, I have to be greater than 0.5. So let me change that. And hopefully when you saw that answer, you're like, no, that's wrong, Miss Meyer, and you would have been correct. We know that if it's greater than, it's going to be one-tailed. If it's not equal to, it'll be two-tailed. For this problem, do not write out the hypotheses. Rather, just state your null hypothesis and which direction you would go. For our first example, we have p equals 0.5. The reason we have p equals 0.5 is if Diet Coke and Diet Pepsi are equally appreciated, then my probability should always come out at 50%. But since I don't know if it's Diet Coke or Diet Pepsi, it could be north or south. For part B, again, it's going to be 0.5 because the question is, we want to appeal to teenagers, and all it says is more teenagers. Well, more is a majority, just like the last problem, that's more than 50%. And since we're doing more, we're going right. C was pretty straightforward. Because they need a 2/3 majority, that's why I have 0.67. Does that mean if I don't see 2/3, I assume 50%? Yes, you do. And I need more than 2/3 majority. Will the stock market go up or down? There's your hint that it's a two-sided test. Just go ahead and explain what that means. That probably means you should write the sentence. So what I've done is I've showed you where your p and p hat values are going to go for. Here's your null hypothesis, the old treatment, and we're going to compare that to what we see in the new treatment. So a p-value of 0.047 means if the true proportion of persons who are relieved with the traditional ointment were, in this case, X, then the observed proportion of persons relieved by the new treatment would be seen 47 times out of 10, 100, 1,000. With a p-value, I'm going to assume an alpha of 0.05. With a p-value so small, I reject the null hypothesis. I have evidence the traditional ointment is helping our clients the way it always has been. What I've done here is I'm showing you where your p-value and your p-hat value would come from. My null hypothesis is that the traditional ointment works very well, and my alternative hypothesis would be that the new treatment works better. So in other words, we're going to test p-hat greater than p. A p-value of 0.047 means if the observed proportion for the traditional ointment were the actual proportion, then I would see the proportion for the new treatment 47 times out of 1,000 in random sampling. With a p-value so, I don't know, how do you want to look at that? If alpha is 0.05, it's so small, and if alpha is 0.01, it's so large. With a p-value so small, I reject the null hypothesis. I have evidence the new treatment works better. With a p-value so large, I fail to reject the null hypothesis. I have evidence the traditional ointment works better. You're going to want to write that out for yourself so you can compare and contrast those statements. For question number 13, write a null and an alternative hypothesis, and then decide when you would reject or fail to reject based on the information given. Since we have no actual probabilities, we're going to talk about our null and our alternative hypothesis in words. Our null hypothesis would be that the old scanner is great. Working fine, no problems. Our alternative hypothesis is that the old scanner is not great. In other words, the new scanner is significantly better, because that's what we're testing, that the new scanner is significantly better. And his decision says at 0.05, he has statistical evidence that the old scanner is not great. Because if he has evidence that the new device is significantly better than the current scanner, then he is rejecting the null hypothesis and has evidence for the alternative hypothesis. Since he's going to reject at 0.05, p has to be some number less than 0.05. If he changed his alpha to 0.10, he would still reject his null hypothesis because the value has to be less than 0.05. However, if our researcher here changes alpha to 0.01 and my p-value is somewhere between 0.01 and 0.05, he could fail to reject. That's p-hacking in action, deciding what value after the fact would help you reject or fail to reject an outcome. For number 17, check your assumptions and conditions. Perform a 98% confidence interval. After you've found that value, you're going to look at B and C and try and come up with some good answers. Here's number 17 worked out. I dug out my N and my X. I found my 98% confidence level using my calculator. I remind myself that the confidence interval formula is this. Do my assumptions and conditions. I can proceed with 0.51 and my standard deviation came out to 0.01. When I do my math, my confidence interval goes from 48.6% to 53.34%. All of this we know how to do, we're confident with. Part B is where it gets interesting. So Part B asks, do I have evidence that the number of male shoppers is higher than 45%? If I look at my 98% confidence interval, both of my boundaries are greater than 45%. Because both of my boundaries are greater than 45%, I have evidence the proportion of men who grocery shop is greater than 45%. If 45% had been inside my boundaries, I would say that I don't have evidence of a different proportion. So because both of my boundaries for my confidence interval are above 45%, I reject the null hypothesis and I have evidence of the alternative hypothesis. Part C says, what's the level of significance of this test? We started talking about this a little bit. If I have a 98% confidence level, then that means I have 1% left over on each end. So you could say that my alpha level is 2% and you would be horribly wrong, but that's okay. We have to go back to the interpretation of our hypothesis test. I have evidence the proportion of men who grocery shop is greater than. So really, I'm only looking at this bit, which would make my alpha level 0.01. It's often confusing to students that a 98% confidence level would go with a 0.01 alpha. We need to remember that a confidence interval is the central percentages and the values left over have to be split in half. So even though there is 2% of data left over, because I'm only looking at the upper tail, that is an alpha level of 0.01. This last question is where you're going to put it all together. You're going to do the confidence interval, and then you're going to test a hypothesis based on the same data. And we're going to look at how the confidence interval and the hypothesis test interact. In part A, we found our p-hat, which is 0.45, and our n. All conditions are met, so I proceed with 0.45, and I find my standard deviation to be 0.013. A 95% confidence interval gives me 1.96. After I do my math, the approval rating, I believe, I am 95% confident, the approval rating is between 42.5% and 57.5%. We need to remember to write these in. I'm going a little too fast. I move on to my hypothesis test. My hypothesis is that his actual approval is 50%. My alternative is that his approval is less than that. I set my alpha, find my z-score, analyze my z-score, and then the sentence. A p-value of 0.00005 means if the true proportion of persons in favor of President Obama were 50%, I would see the observed proportion of persons at random 5 times in 100,000. With a p-value so small, I reject the null hypothesis. Since I am rejecting the null hypothesis, I have evidence that the actual proportion is less than 50%. Make sure you bring any questions you might have to our next class. I'm going to give you 2 multiple choice questions. You will answer those on... Make sure you bring any questions you have to class. I'm going to add 2 more multiple choice questions to the end of the video. Pause the video, answer the questions, and bring your answers to your next class. That will be proof that you watched the video and you've taken good information from it. Here's your first question. Which of the following is a true statement? Here's your next question. Again, which of the following is a true statement?